Hey guys, today we're going over the review for the first test of the second quarter. This is over our transformations unit and our parallel lines cut by transversals units. So let's go ahead and get started. Part 1, it says use the picture below to answer questions 1 through 5. What is the angle relationship? So number 1, they're talking about angles 4 and 6. Here's angle 4, here's angle 6. Those are both on the inside of the parallel lines and they're on the same side. So we call this same side interior. And there's a word bank below, so you can go ahead and cross that out. Remember, the other name for same side interior is consecutive interior. All right, number 2, 1 and 8. Here's angle 1, here's angle 8. Those are both on the outside, so they're on the exterior, and they're on opposite sides of that transversal line. So those are going to be alternate exterior. Number 3, they're asking us for angle 6 and 8. Here's angle 6 and here's angle 8. They're right next to each other. They form a line, so we call that a linear pair. Now number 4, it's asking for angles 4 and 5. Here's angle 4 and here's angle 5. Those are both on the inside, but they're on opposite sides of that transversal. So we're going to call that alternate interior. And then our last one is talking about angles 2 and angles 3. Here they are. They are immediately across from each other, and we call those vertical angles. All right, next section, part 2. It says answer the questions below about each of the pictures. Show all of your work to receive credit. Put your answers in the box provided. So number 6, first thing they want to know is the angle relationship. Both of these angles are on the outside of those two parallel lines, and they're on opposite sides of our transversals, so we call that alternate exterior. Next question, congruent or supplementary in the equation. Alternate exterior angles are always going to be congruent, which means our formula is part equals part. And then the last question says, what is the value of x? So we need to set up our equation and solve it. We just said it's part equals part, so we're going to do 5x plus 8 equals 6x plus 4. We always want to start by moving the smallest x, which is the 5x here. Right now it's positive, so we need to subtract it on both sides. 5x minus 5x makes 0. We can cancel that out, bring down the 8. 6x minus 5x makes 1x, and bring down the plus 4. And then our last step here, to get x by itself, we need to move that 4. We're going to do the opposite, so we're going to subtract 4 on both sides. 8 minus 4 is 4. Bring down your x, and the 4's cancel out. So x is going to equal 4 on this problem. All right, number 7, same thing. They are asking us for the angle relationship to start off with. Both of these angles are on the inside of those parallel lines, and they're on the same side of this transversal here. So we call that same side interior. Or the other name is consecutive interior. Same side interior angles are always going to be supplementary. So that's the answer to the next part of the question. And supplementary means they add up to 180. So our equation is part plus part equals 180. So we're going to go ahead and set that up and solve it. One part is 7x minus 10 plus the other part is 5x plus 30. And we just said it should all equal 180. Next up, we need to combine like terms. We've got 7x plus 5x. That's going to give us 12x. And then we have negative 10 plus 30, which is going to give us positive 20. And then we just bring down our 180. Next, we need to move the 20 to the other side. So we're doing the opposite. We're subtracting 20 on both sides. Bring down your 12x. The 20s cancel out, and 180 minus 20 is 160. And then our last step, we got to get rid of the 12 in front of the x, so we need to divide by 12 since they're attached to each other. So 12s cancel out, and 160 divided by 12 is going to give us 13.33. So the value of x is 13.33. All right, so on page 2, we're doing the same process here. These angles are a little bit different because we do not have parallel lines cut by transversal. It's just 2 lines. So the angle relationship here, they are directly across from each other, which means they are vertical angles. Vertical angles are always going to be congruent, which means that our equation should look like part equals part. So now we're going to go ahead and set up and solve this. We've got 60 equals 3x minus 18. We need to start by moving the 18 to the other side. We're going to do the opposite, so we're adding it. 60 plus 18 is 78. Bring down your 3x, and the 18s cancel out. And then our last step, we need to divide by 3 on both sides to get rid of it. So x is going to equal 26. So that last question, the value of x equals 26. All right, next one, number 9. This question is wrong here. That's not what it's asking for. We're still looking for the same things in that box over on the right side. They said, what is the angle relationship? Both of those angles make this straight line down here together, and we would call that a linear pair. Linear pairs are always going to be supplementary, which means they add up to 180. So our equation should be part plus part equals 180. So let's go ahead and work that out over here. One of the parts is 5x minus 30 plus the other part is 6x, and we just said it should equal 180. So first thing we need to do here is combine like terms. 5x and 6x are on the same side, so we're going to add them here because it says add. So 5x plus 6x makes 11x. We're going to bring down the minus 30 and bring down the 180. Now there's nothing else to combine, so we can start moving things to the other side. We're going to start by moving the 30. We're doing the opposite, so we're going to add 30 on both sides. So bring down your 11x. The 30s cancel out, and 180 plus 30 is going to give us 210. And then our last step, we need to divide both sides by 11 to get rid of it. So the 11s cancel out, and 210 divided by 11 is going to give us 19.09. So the value of x is x equals 19.09. All right, for part 3, it says match the correct slope in questions 10 through 13. And over on the right side, they've got kind of like an answer bank over there. So number 10, it says perpendicular lines have blank slopes. So if you remember, we said for perpendicular lines, you need to change the sign and flip the fraction of the slope, and the fancy words for that are opposite reciprocal. So that is our answer here. Perpendicular lines have opposite reciprocal slopes. Number 11 is talking about parallel lines. For this one, parallel lines have to have the same slope, the exact same number. Number 12, horizontal lines. If you remember, we talked about hoy and bucks. Horizontal is hoy because you have your H right there. The middle letter tells you what the slope is. So here our slope is going to be 0. And then the last one, number 13, is talking about vertical lines. That's the other part of our acronym, which is bucks. The V stands for vertical, so that's how we knew that. And again, the middle letter is your slope. The U stands for undefined. Next section, number 14, says find the slope of the line that contains 11, -2, and -7, 5. So for slope, we've got a couple of formulas. The one that we need to use when we have 2 coordinates is m equals y2 minus y1 over x2 minus x1. And we want to make sure we label our coordinates before we plug them in so we know exactly where everything goes. So our first coordinate's 11 and -2. That's going to be our x1 and our y1. And then the other one's -7 and 5. That's going to be our second set. So it's going to be x2 and y2. So now that we've got our coordinates, we can go ahead and plug them into our formula. First thing is y2. Instead of that, we said it was 5. minus y1, which if you look, it says -2. Now be careful here, there's a minus sign from your formula and a negative from the -2. Leave them both there. And the bottom part, x2 is -7 minus x1 is 11. Now from here, you would just go ahead and type it straight into your calculator so that you don't mess up the math. And if you forgot to get a fraction in your calculator, you press the buttons alpha, y equals, and then enter. Once you type that in, it'll give you your answer, which in this case is -7/18. So there's our slope. For number 15, it says the equations of two lines are -3y minus 9x equals -6, and y equals -3x plus 1/4. And they're wanting to know whether these lines are parallel, perpendicular, or neither. So what we need to do here first, if you notice the second equation is already in y equals mx plus b format, which is great. The other one is not though, so we need to fix that equation first. We need to solve it for y before we can get our slope from it. So we're going to move that x to the other side, which here it's negative, so we are going to add it on both sides of that equation. So bring down your -3y, the 9x's cancel out, and the 9x, we cannot add it to the -6 because -6 does not have an x next to it. So we're going to leave those two things separate. We've got 9x minus 6. And then our last step here, we need to divide both sides by -3 so that we can get y by itself. So -3's cancel out here, just bring down your y. 9 divided by -3 is -3, and you can bring down your x. And then -6 divided by -3 is a +2, so we're going to put +2. All right, so now we can look at our slopes for this line that we just figured out. It's going to be -3, because remember, it's always the number in front of the x. And then for our other equation that was already solved for y, it also has -3. So if you notice here, they have the exact same slope, which means those two lines are going to be parallel. All right, number 16, it says write the equation of the line passing through the given point that is parallel to the given line. So this is where we are going to use our point slope formula, which I will write down here for you. And what we're wanting to do, they gave us the point, so we're going to go ahead and label that. It is always going to be the one with the 1, so x1 and y1. It is not regular x and regular y. And then the other letter there that we need to fill in is the m, which is the slope. They said they want a line parallel to the given line, so that means we want the exact same slope that they gave us already. Okay, so we want to use the -3,2 for our m. Just as a little side note, if they ask for perpendicular instead, don't forget that you need to change the sign and flip the fraction. So we're going to go ahead and write that off to the side. Perpendicular. You change the sign and you flip the fraction. Now again, this one's asking for parallel, so we don't need to do these extra steps, but just in case that they're asking for perpendicular, those are the steps you need to take with that slope. So for this problem, we can just go ahead and plug in the y minus is going to stay there. We said y1 was 0. M is -3/2. And then in the parentheses, we've got x minus and x1 is 6. Now we should always try to simplify if possible. The only thing we can simplify here is the y minus 0. If we subtract 0 from anything, it's still going to be the same thing, so we can just get rid of it. So it'll just be y equals -3/2 x minus 6. All right, for number 17, it says which graph best represents the line passing through the point 0,4 and is parallel to y equals -1/2 x. So we know for sure it's got to go through this point 0,4. And if you look at each graph, all of them are correct with that point. Here's 0,4, all of them are going through that point. So the part we need to check out and see if it's correct is the parallel part. So for parallel, we want to have a slope that's the exact same as this line they gave us. So we want -1/2. First of all, it's a negative, so that means our line should be going down as it goes from left to right. A is going up, so that's definitely wrong, and B is also going up, so that's definitely wrong. C and D are going down, so we know those are both negatives. Now we just need to check their numbers. So don't forget your slope formula when we're looking at a graph is rise over run. So we're saying since our slope is -1/2, that it's going down 1 and to the right 2 every single time. So let's start with that point. We already have it 0, 4. So for answer C, we should be able to go down 1 and over to the right 2. That looks like it checks out. Let's do one more just in case. Down 1 and over 2. Looks pretty good. Let's check answer D just to make sure. For answer D, we'll start at our point 0, 4 again, and we want to go down 1 and to the right 2. And you can see that line is not going through that dot. So answer D is out. Answer C is our correct answer. Next problem, number 18. It says, which composition of transformation was used? Hint, make a T-chart. Now, normally we would make a T-chart for every single one of these answer choices. And since these are compositions, it might take a little while. So we're going to go look at our answer choices first and see which ones definitely don't make sense. Remember, your original is the one without the primes, which are the apostrophes. And that means your new one is going to be this one down here with the apostrophes. Okay, so if you look, the one on the top right going to the one on the bottom left, it's getting smaller. So if you remember when we talked about dilations and scale factor, if your picture is getting smaller, then your scale factor should be between 0 and 1. So let's go through our answer choices and see which ones have that. Answer A, that dilation it mentions is 2. We just said that's not correct because we want it smaller. So A is out. For answer B, it's the same thing. The dilation, the scale factor is 2, which means it'd be getting bigger, and we just said it is not, it's getting smaller. So answer B is out. Answer C, dilation, the scale factor is 1/2, which should check out because we want something between 0 and 1 since it's getting smaller. Same thing with answer D, it's between 0 and 1, so that should work. Okay, so now we're gonna go ahead and do our T-charts. We already eliminated A and B, so we don't need to do it for those. We just need to do C and D. So we're gonna do those off to the side. I'm going to do C on top, and I'm gonna label it so I don't forget which one I'm working on. We've got 2 transformations going on for both of these answers, so we're gonna have 3 columns in our T-chart. The first column is always our original X, Y. And here you don't have to do every single point. If you just check one, it should help a lot. So let's just go with 1 point at a time. I'm gonna go with point A. So the original coordinate A is at 1, 2, 3, 4 to the right and up 2. Now the first transformation, they said they wanted a dilation with a scale factor of 1/2. So that means we're going to multiply both the X and the Y by 1/2. So A prime, half of our X, which is 4, is 2, and half of 2 is 1. And then we're going to do the second part of our transformation. They said they want a rotation of 180 degrees counterclockwise. If you go look at your formula chart, 180 counterclockwise, the formula is negative X, comma, negative Y. Now remember, when we're doing a third column, you need to cross off the first column. We do not want to use that anymore. We're doing this change based off of the middle column. So now we've got a double prime. And here are the changes that we want to change the sign of both the X and the Y values. So the positive 2 is going to become negative 2, and the positive 1 is going to become negative 1. All right, so now we want to go ahead and graph this point and see if it is correct. Negative 2, negative 1 means it's going to the left 2 and down 1. There it is, and as you can see, it does match up correctly with our A double prime. So that should be our correct answer. We're going to go ahead and check D, though, because sometimes we make a mistake. Let's go ahead and look at D. Again, we are doing a T-chart with 3 columns. The left column is still our originals, X and Y. And we're going to go ahead and check A again, which was at 4, 2. So this time for answer D, they want a dilation with a scale factor of 1/2, which happens to be the same as the last one. So we're going to do 1/2 times X and 1/2 times Y. So A prime, half of 4 is 2, and half of 2 is 1. So there's A prime. And the second part, they want us to rotate it 90 degrees counterclockwise. So we're gonna go look at our formula chart. 90 degrees counterclockwise, the formula tells us we should do negative y comma x. Don't forget, cross off the first column because we are not changing that anymore. We're looking at the middle column now. So since our rule is negative yx, that means we need to change the order of the numbers and we need to change the sign of our y value. So for a double prime, now the 1 is coming first, but they want us to change the sign, so it'll be a negative 1. And then it's our x, which is 2. So here we're saying our coordinates should be negative 1, 2. Let's go ahead and check that out. We're going to the left 1 and up 2. And as you can see here, clearly that is not part of the new triangle or even the old triangle. So that one's definitely wrong. And like we said earlier, our answer is going to be C. All right, for number 19, triangle ABC has vertices at A, 8, negative 6, B at 1, negative 3, and C at 1, negative 9. What are the coordinates after the composition of transformation shown below? Hint, make a T-chart. Now this problem gives us a graph. Technically we don't need to use it because it's not saying graph. And for this translation and rotation, we can just use a T-chart anyways. So we're gonna go straight into that. Since it's asking for 2 transformations, we're gonna need 3 columns. The first column is always the originals, which are x and y, and we're gonna write down those coordinates they gave us. A was at 8, negative 6, B is at 1, negative 3, and C is at 1, negative 9. All right, so let's go ahead and make our changes. Remember, you have to go in their order. So the first thing we're going to be doing here is the translation. So we're going to go ahead and write our rule up at the top. They said they want to do x minus 1 and y plus 5. So we're just going to plug in our numbers to this formula. So first thing is a prime. We're doing x minus 1, so 8 minus 1, which is 7. And then instead of y plus 5, we're doing negative 6 plus 5, which is going to give us negative 1. Next one, b prime. We are plugging in again, so 1 minus 1 is 0, and negative 3 plus 5 is 2. And then for the last one, c prime, 1 minus 1 is 0, and y plus 5, or negative 9 plus 5, is negative 4. All right, so now we can do our last transformation. Remember, when you move to a new column, you need to cross off the first column because we're not using that anymore. And now we are going to do a rotation. So here you need to go look at your formula chart to make sure you're using the correct formula. 180, whether it's counterclockwise or clockwise, our formula is going to be negative x, comma, negative y. So let's go ahead and make those changes. A double prime. They are wanting us to change the sign of both numbers. So positive 7 is going to become negative 7, and negative 1 is going to become positive 1. For b double prime, 0 is not negative or positive, so it's just going to stay. And then 2 is going to change to negative 2. And then our last one, c prime, 0 is staying the same, and then negative 4 is changing to a positive 4. So here are our answers after our composition of transformations. All right, on the last page, number 20, they're asking what is the scale factor K used to map ABC to A prime, B prime, C prime. Okay, so for scale factor, if you remember, our formula is new over old. So what we need to do here is measure the same side on both of these triangles so that we can compare the numbers. So our new one, remember that's always the one with the apostrophes or the primes. So that's going to be this shape over here on the right side. Now you can count whichever side you want to. The side that's easiest though is the bottom A to B because it's flat on the line and we can just count squares. So we're gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So the new one is 9. And then for the old one, we have to count the same exact side. So we're still doing A to B. And there's 1, 2, 3 squares. So now we just need to simplify this. 9 over 3 is going to give us 3 for our scale factor. And you can always check your answer. Remember, if the scale factor is bigger than 1, that means our picture is getting bigger. And as you can clearly see here, from the original to the new one, the picture did get bigger. All right, for number 21, it says draw all possible lines of symmetry. If there are none, leave it blank. All right, so letter A, remember lines of symmetry is when you can draw a line any direction and it'll be the same on both sides. So for letter A, we can draw one line going up and down. For letter B, it can go across. Letter C, same thing going across. Letter D is repeating itself, it can go across. So A, B, C, and D only have one line of symmetry each. Now E, same exact thing, going across. F, there are no lines of symmetry on F. There's no possible way you can draw a line and it be the same on both sides. Same with G, there's no way there'll be a line of symmetry. For H, we've got one going across, but we also have one going up and down for this picture. So we've got 2 lines of symmetry for the letter H. For the letter I, it can be going straight across, and depending on how thick your letter I is, it can also be going up and down. For the letter J, there are no lines of symmetry. For K, it's the same on the top and the bottom, so we can draw a line going left to right. For L, there are no lines of symmetry. For M, we can draw a line going straight up and down. For N, there are no lines. For O, we're going to have a lot of lines because no matter what line you draw, it'll be a line of symmetry. So for O, our answer is infinite. For P, there are no lines of symmetry. For Q, we can draw a diagonal line. R, there are no lines. S, same thing, there's no lines. Be careful with S though, it confuses us a little bit, but there are definitely no lines. For T, we can draw a line going straight up and down. Same for U, same for V, and same for W. So T, U, V, and W all have a vertical line of symmetry. For X, we can draw a vertical line and a horizontal line. And depending on how your X is drawn, you might be able to have diagonals. It doesn't work for this one here, and I'll show you why. If we were to draw a diagonal this way, you're on the left side, you got this, which means on the right side, it'd have to reflect and go the same direction. As you can see here, it does not reflect onto the other side, so we would not have that red diagonal line. So it's just the 2 blue lines, so our answer here would be 2. Last 2, for Y, it does have a vertical line of symmetry. For Z, there are none. All right, number 22 says, what is rigid motion? Name the transformations that show rigid motion. So for rigid motion, our definition is going to be that it keeps the same size. They want us to name the transformations that show rigid motion. So those would be translations, because those are just moving, they're not changing. We'd also have reflections, because that's just flipping over, the size isn't going to change. And then there's one more that's going to be rotations. It's just turning, it's not changing size. So then number 23, it says, what is not rigid motion? Name the transformations that do not show rigid motion. So if it's not rigid motion, that means it's going to be different sizes. So you're going to have the same picture, but they're going to be 2 different sizes. So our only one that would be an example of that is a dilation, because with a dilation, it's getting either bigger or smaller. All right, please let us know if y'all have any questions, and good luck on your test.